Yeah, I think scaling is nice and it's been responsible for a lot of performance gains on the benchmarks. I think we are probably at the end of the era of further scaling, just because, at least for text, because we've consumed all of the useful text that we can that's out there. And sure, we're generating more text, but then now you have additional problems that a lot of the text that's generated is itself the output of other LLMs and so forth. So at least in terms of data, it's not even clear how we can further scale. Because also remember the scaling laws, they're like exponential, right? So it's like you need another order of magnitude to get a linear order of improvement on the performance numbers, however you measure it.
All right. So hello and welcome everyone to whoever is tuning into this particular podcast. Today I have with me Dr. Jackie Cheung. He's an associate professor at McGill University in Canada, where he co-directs the Reasoning and Learning Lab. And he's also an associate scientific director at Mila-Quebec AI Institute. He and his team have been developing computational models to improve the reliability, pragmatics, and evaluation of large language models to ensure they are contextually appropriate and factually grounded. Jackie was also a consultant researcher at Microsoft Research Montreal. And before his current appointments, he earned his PhD and MSc in computer science from University of Toronto, focusing on computational linguistics, and his bachelor's from University of British Columbia. So, Jackie, welcome on the show, and thanks for being here.
Thanks for having me.
So, just to learn a little bit more about your background, what particularly sparked your interest in AI and followed by that research in NLP? And how did you end up pursuing a PhD and your career in academia?
Yeah, so as you mentioned, my main research interest is in natural language processing within AI. So really my interest in the field was sparked by my interest in languages. When I was growing up, I grew up in Vancouver, and it was in a fairly multilingual environments where there was English spoken, but also Cantonese and Mandarin and Korean and Japanese. And so I became interested in all of these different languages and how they all sound very different, but they all can express all sorts of meanings and facilitate communication. And so that was what got me interested. So then during my studies, then I took many linguistics classes in addition to computer science classes. And from there, my interest in using computation as a way to think about language grew. And so that's why I got into NLP, and I started doing NLP research at the University of British Columbia. And from there, it just became a very natural extension that I kept going in that direction.
And was it anything specific to the AI algorithms? Like you have your background in linguistics, you have like a very deep passion for understanding and working with linguistics. But like, was it something specific about AI algorithms that sounded more appealing to you? And like having a combination of both of things tied together would make something very interesting.
Yeah, I would say it wasn't very conscious at first, but over time I came to realize that using computation as the main way to think about language lets you think about things a lot more systematically. So, for example, sometimes there are different linguistic formalisms that people use to analyze language. And on the surface, they might look quite different from each other. But then you can prove formally that some of these representation systems are actually equivalent. So, things like that, right? So, it's really through the power of thinking through things algorithmically that you can achieve a lot. And also thinking about data and computation, I think is really important. So it's one area that, especially at the time, maybe less so these days, but at the time really differentiated computational linguistics from maybe other sub areas of linguistics in that um, thinking about data and thinking about the messiness of language in corpora and coming up with algorithms and systems to process that, that was a really interesting and important challenge. So that's really what got me hooked. And it's like, so it's about working with data, working with the complex situations that you find in naturally occurring text that you can gather online or elsewhere, and then coming up with maybe at the end technologies that could be useful using that type of approach.
Right, right. And throughout your whole career, you have also interned at a bunch of places, did research with like multiple advisors, like on multiple topics. What was your rationale behind choosing academia for your long-term goal over industry? Like, how do you see the differences between these two sectors contributing to AI research broadly?
Yeah, I think it's a combination of maybe personal preferences and also practical matters. So, working in industry is great and wonderful. I feel that being in academia, what I do, somehow I have a greater sense of ownership over it. So in both cases, in both industry and academia, you're going to have constraints. There's nothing as like absolute freedom in pursuing the direction of your choice. It's just that there are different constraints. In academia, maybe you have less pressure and constraints on doing things that are immediately commercializable, but you need to do things that are publishable and that can be funded by research grants. Whereas in industry, then you might have a little bit more pressure and depending on the specifics of the company and the position, to do something that's more a little bit shorter, more short term. So for me personally, I felt that in academia, I could have more control and direction over the kinds of research that I do. So that's one factor. A second major factor is that in academia, I get to work with great grad students and I get to mentor more junior students, and that's really appealing to me. So that's something I want to do. You can do that in industry as well, but usually it's to a lesser scale, in that industry researchers might take on interns, or they might work in teams where there might be more senior or junior people, but it's not at the same scale. And the third reason is more practical in the sense that at the time when I was applying for jobs and looking, I wanted to stay in Canada. And at the time, there weren't that many industry research positions in Canada in the first place. So that meant academia was the place to be to research in NLP in Canada.
Nice, nice. And since you also had like this stint working with Microsoft Research and broadly like just analyzing how different research works are done in industry, in academia, and also something at the intersection, how do you see the field in 2026? Like, is there like a bit of silo of like how research is conducted in industry versus in academia, or like they are more like a in a conjunction, like they complement each other? Like, how do you see across different labs, different institutes nowadays?
Yeah, I'd say that there is a great deal of diversity and variety on how research is incentivized and done in industry and academia. So it's highly dependent on the specific position. Even within the same company, there are likely to be very different positions where the evaluation structure and the measurements of progress will be different for different positions. So it's hard to make a general comment about academia versus industry. I would say that the way I see it in industry, there's some positions that are still more research focused and that they're gearing towards publication, open publication, so more fundamental research driven. But there's now a large part of industry research which is more company specific and company internal. And there's a greater focus on delivering value and delivering specifically commercial value and product value to the company. And that's not a bad thing. That's great. It's a great place to be, and that could be some of the most impactful work that can be done. So, but it's just different. It's a different way of structuring research. I would say in academia, there's also great diversity because it really depends again on the specifics of your position. There are some positions that are entirely research based. So there could be, I think in the US, they tend to call them soft money positions where maybe there's no tenure, but as long as you can keep the grants coming in, then you can work on whatever research you want within the scope of those grants. There are some that are like the typical, or I guess the traditional tenure track faculty would have some combination of research and teaching and service. And then there yeah, you do research because you find it interesting and useful and impactful, but you still need to demonstrate research impact. And yeah, and then there are other positions where there's a heavier focus on teaching, and then the research you do could be maybe smaller scale or could be more focused and targeted. And that would also be, for example, there's a lot of great research where people in more teaching oriented positions do research on teaching and the use of AI in education, for example. So there's a whole broad range, and it really depends on the way that your position is set up and the environment that you're in.
Yeah, yeah, definitely. Like I have seen, like one thing I've noticed is we have like much more broader area of topics where a particular set of research topics are applied within academia versus there is like much more narrow focus in industry, which is again, like you said, like it's very complementary. One thing benefits from the other, but one of the beauty being in academia is like you get to explore so many different avenues of applying a particular research. And tying to that, like one thing I did notice before we deep dive into any of your research projects, I noticed you also have worked on language revitalization using AI. Like, can you talk to that about a little bit more? Like, what exactly was your motivation? What exactly you have been doing, and what is the rationale behind language revitalization?
Sure. Yeah, that's a great question. So the way I see it, now we have all of these large language models, and they're out there, and they're deployed by these big players, by industry primarily. And so this technology is here, and it's here to stay, and we have to learn to work with it and live with it, and so forth. So the motivation for this part of my research in language revitalization is to try to make sure that there are more people whose voices are heard, and that there's more of a distribution of who gets a say and who gets control, or at least who gets to participate in the process of deciding how this technology is developed, and how it's used, and who gets to use it and for what reasons. So a lot of this work is even driven more bottom up by my students who are in language communities where they're facing some of these issues and they want to do something about it. So, for example, my PhD student Caleb Moses, who is co-advised with a professor in the Department of History of Noelani Arista, he has been doing great work on Maori language revitalization, and there are particular concerns with data sovereignty that are relevant, and so he's able to contribute to that and make sure that the voices of his community and the needs there are heard. I have another PhD student, Bonaventure Lasu, who works in African language NLP because he's integrated into that community and he's able to contribute some projects in that space. So really the motivation there is about, making sure broadening the set of players and broadening the set of people who have a voice in how this technology develops.
I see. And so the rationale behind that is like to make sure certain biases are not picked up or like amplified by these large language models across different segregations, or like how exactly does that um, get like implemented in place? Like, what is the technical definition of like making sure these voices are heard when we are training these large language models?
Yeah, I think that's one aspect of it. But I would say that even before that, there are many other aspects. A lot of it has to do with just deciding should you be using AI technology for that community in the first place. So you need to get buy-in. And the second could be issues to do with, say, I mentioned data sovereignty, right? Well, so what that refers to is who gets control of the data and who gets to give permission for that data to be used to train large language models. And if that data is used, then who gets a say on how that large language model is deployed and what is deployed for. So there are many, many issues. So a lot of these are not purely technical issues, but maybe social technical. And it's a combination of the factors of the the community as a stakeholder, and maybe members of the community and different subgroups of the community as stakeholders, and also the researchers and the companies. So it's an interaction between all of these different groups, and the governments, and the regulations and laws that are there as well. So I would say that eventually then you do come to this point where, there are specific technical issues. And so, for example, Caleb's current project is about connecting the values and the community-driven needs of that arise in that context with the protocol and with the methodology and with the technical aspects of NLP technology. So it's about really the connection between these two that's important to me. And that might turn out to surface as, oh, we need to make sure this particular bias on this data set or in this evaluation is corrected for. But there's the argument there is like there's a whole process before we get to that technical point.
Yeah. Yeah. No, I mean, I love that. Like, this is a very important problem to work on. And like, I would imagine like it's much more complex, like how it more than it sounds. So definitely this feels like a long-term project. And definitely requires like lots of efforts. So yeah,
Yeah, there's so one thing I will point out is that is there's a lot of qualitative work that's involved, which is also me stepping outside of my comfort zone, right? So I was trained primarily as a computer scientist, and so I'm used to like working with all of these quantitative models, statistical models, and equations and loss derivations and so forth. But this type of work it requires a different style of thinking as well. So you still need all of the technical stuff, but you need to pair it with some qualitative work. So that's been very interesting and eye-opening for me.
yeah, definitely. And yeah, and like, I mean, I would definitely leave to like leave links in the YouTube video down so that people can check out like if there are any interesting works that you have published or like posted it out on online. So like people who are interested to maybe contribute or learn more about how to contribute to certain projects, they can check it out. So yeah, thanks for sharing that. And to switch gears to more learning more about your active research, you have also investigated how LLMs as just like there has been a trend in the research field of using LLMs to evaluate LLM outputs, like basically LLMs as judge. Like I wonder, like in your investigation or like more like a evaluation study, how what were the findings in general that you found when we use LLMs as evaluation in the first place, and like a much more follow-up question to that is like, for example, if we establish that we cannot use LLMs to grade LLMs in the first place, how do we establish this scientific goals that typically drives these agents or like models in the first place? Like I'm curious to learn more about your thoughts. How do you feel about this whole setup of using LLMs as judge?
Yeah, sure. So I think you're referring to a position paper that Lee wrote. So this was led by my PhD student, Khala Chaboni, who's in my lab and also in the lab of Professor Golnish Farnadi. And so in that work, our argument is that it's a bit premature to use LLMs as judges uncritically. So we examined this through the lens of measurement theory. So essentially, measurement theory is the science and study of how you take measurements of things you care about in the world. And this is very broad. It applies to AI evaluation, but it also applies to, say, taking measurements of physical quantities or physical attributes like temperature or whatever. But applied in this kind of a setting of AI evaluation, what we did was we collected and looked at a whole bunch of different prior studies, and we put together an argument that based on all of this work, it really there is a lot to be questioned about the use of LLMs as judges. So in terms of measurement theory, two basic concepts that are relevant are validity and reliability. So validity is the idea that what you're doing, how you're taking the measurements, corresponds to some goal that you're interested in, or some construct or a latent quality that you're interested in. So that's validity. So and then reliability is this idea that um, your measurements are consistent if you repeat them in similar conditions. So basically, what we found by looking at all of the recent studies in the literature on using LLMs as judges is that there are a lot of validity concerns, and so that really calls into question um, whether we're well prepared and whether there's enough evidence to use them um, directly without further experiments. So, for example, I would say the predominant way in which LLMs as judges are currently validated is by comparing the outputs of LLMs as judges with human annotators. So, right, so the idea is you get human experts, hopefully, to do some annotations and get some outputs. Some. It could be preference judgments. It could be some linguistic annotations, whatever. And then you get the LLM to do the same thing, and you show that there's a good correlation between them. And then you say that, okay, great, then we're done. But it turns out if you actually look at many of those studies, even on the human side, it's not that well done or not that well standardized, which means that correlating against this might not be the best evidence. For example, we found that in a lot of the human subject studies and experiments, in a lot of the protocols that are used there are different one from the other, but yet they're compared against each other. So you're comparing things they're not well controlled. There's been a lot of other work that look at the issue of reproducibility of human judgments. So, for example, there's this work on repro-hum, which is like reproduction of human annotators. So led by people, really great researchers like Edward Reiter and Anya Beltz. And then they found that there are lots of issues with the reproducibility of human subject experiments. And so if you're correlating against something that is itself um, not well established, then you're going to run into troubles. So that's just one example of a validity issue, a potential validity issue we found. We documented several others. And so yeah, another type of issue that we found, which is also well known, is that the LLMs as judges are highly sensitive to minor changes that they ideally should not be. For example, minor changes in the prompt and the wording, or in, say, the way in which you order possible outputs, so that's position bias, can drastically change the outputs that they give, the judgments that they give. So some of this could be fixable, right? So position bias, maybe you can try to fix it by trying all possible orders, and then you take an average or something. So I'm not disputing that, but the issue is that it really does seem to suggest that the LMs as judges, they don't seem to be using the same kind of reasoning chain as maybe humans, expert annotators would. And so all of this added together means that we should be a bit wary. So I'm not against using LLMs as judges completely, but it does mean that for a particular deployment setting, you have to think a little bit more carefully and do maybe a little bit more validation before directly using them.
Yeah, yeah. And now it makes sense, like regarding your first point, like your critique is along the lines of like not where LLMs using like the framework of using LLMs as judge might be failing or not, but comparing it to a certain set of ground, like what we call as ground truth or the human annotations, they might be noisy or like incorrect, and that's one of the reasons why it might be failing. So just using this whole design framework and using human annotations as the reference framework to evaluate a performance of large language models, the whole setup design is much more of a problematic issue, and that is where your critique lies, right?
Yeah, that's definitely one of the important points. Yeah. I'd say another major point would be just the giving definitions, giving good definitions. So a lot of the work we examined, they asked LLMs as judges to to evaluate fluency or to evaluate correctness, and then they ask people to do the same thing. But often they don't even give good definitions of what they expect. And so I think this will maybe come up again a little bit later once you start talking about safety and issues related to that. But yeah, that's another major issue.
um, but I wonder, like, is there like an easy or feasible solutions to this? Because I would imagine it's like a very open-ended question to have
Mm.
a certain set of evaluation. For example, like I'm just trying to think of an example of where an LLM would generate a huge output, and I were to imagine, like for example, let's say if I were to summarize a paper, right? Like if I give it a paper and gives me a summary, but you can always critique that it might miss a bunch of things or versus it might not, right? So like how do I generate the ground truth summary that one thinks that this is the most apt version of summary, and then I can correlate that embeddings with the LLM embeddings and make sure it has like a very high correlation. Is there like an easy, feasible solution to achieving this and getting rid of this problem with ground truth annotations in the first place?
No, I don't think there's an easy solution because if there were, I think we would already be doing it in the field. But I do think there are best practices to move us closer to having a good state of affairs and evaluation. So some of it will really just be documenting what you did and documenting how you prompted the human experts versus the LLMs and make sure it's consistent. Some of it is giving good definitions and good conceptual definitions that are well grounded in some theory. Usually, it might be a theory in the sense of a concept in linguistics, or maybe a theory in the sense of something from the social sciences, if it's more related to AI and the impact on safety and society. So I think those are the starting points. Another good starting point would be to talk about the deployment specific concerns and issues. And this might require consultations with the users you anticipate will use your system. And so the goal here is to really think in a more context specific way, so that you can make all of these issues more and more well defined and iterate towards a better evaluation. And once you have that setting, then the experiments about correlating LLM judgments versus human judgments would make a lot more sense, and then they would be a lot more trustworthy.
Yeah, that makes sense. And talking about like the experimental design, you also had this very nice paper where you suggest a framework called ECBD, evidence centered benchmark design. Like, can you also elaborate? Like, I would imagine that it's super correlated to the discussion that we are having just now. Like, what kind of design framework? Like, what was the problem that you noticed, and what was the framework that you end up coming up with that is relevant to making sure that we have a much more holistic, context dependent experiment design rather than having like one shot solution that solves all the problems?
Yeah, sure. So this was work that was led by my former student Yu Liu and also collaborators at Microsoft Research Montreal. So the the starting point for this work was we were looking at the trend of creating more and more benchmarks in NLP and evaluation. So it seemed like every week there was a new benchmark coming out, and there were also benchmarks coming out that were big collection of other benchmarks. So it's like here's a benchmark; it collects maybe 100 other different smaller benchmarks from prior work, and then you can now use it to evaluate your LLM, and then you get one score or maybe some number of scores at the end. So this work was sparked by that trend, and we wanted to really think about what makes a good benchmark, and and how can we ensure that people who are creating benchmarks have some guide to help them do that? Because the state of affairs, and I think it's probably still fair to say this, it's still the case, is that people validate benchmarks again by looking at things like inter-annotator agreements. Like you get multiple people to collaborate or to not collaborate. You get multiple you get multiple people to annotate the same data, and you see, do they agree on the label that they assign, or do they produce similar outputs, text or preferences? And if they do, you think it's a good annotation. Otherwise, maybe it's not a good annotation. So that's kind of the typical state of affairs that you see in a lot of NLP benchmark creation works, and that's one approach, but it's really not getting to the broader point of there are many other considerations that you need to justify that you've created a good benchmark. So in this work, what we did was we drew inspiration from other fields that have had to face similar issues in evaluation. In particular, so in education assessments, there is a similar framework, which is called evidence-centered design. I think I might have on one of the words wrong, but anyway. So the idea is that in student assessments, you have a similar issue that the things that you care about are fuzzy sometimes, and then educators need to have a clear way to design quizzes or tests that targets the capabilities that they're assessing for in students. So we took that general idea and we applied it essentially to NLP models. So to make it extremely clear, we're not saying that the exact same test that's applied to students and to people should be applied to LLMs. We're not saying that at all. In fact, I think usually that's not the right way to go. What we're saying is that some of the concerns in how you set up the tests and the assessments will also apply, and you can take that to come up with a structured framework for ECBD. So the way that ECBD works is essentially it separates the benchmark design process into multiple components, and it asks for justification and documentation of reasons for each of those components. So one of the first ones would just be, what is this benchmark designed to be used for? What is its purpose or goal? And this seems like a really basic thing, but it's often not well specified in a lot of the benchmarks that we examined. So if it's meant to test for reasoning, then that's great. So can you be precise about what you mean by reasoning? If it's meant to test for a certain test for reasoning among a certain class of models, can you say which are the classes of models that you aim to compare and evaluate? And is it fair to compare people versus models with your benchmark? Another one is more based on content. So that's the content module. So do you have a good justification that the selection of samples in your benchmark cover the capability that you care about and are representative of a capability you care about. So this is the general idea behind this work in ECBD is like we go through and give a list of components and we give a structured way for benchmark creators to document and justify their decisions. I'd say
Right.
that another use of this framework that we didn't explore as much, but I think it would still be applicable is for people who aim to do their own evaluations to reusing an existing benchmark. And then this framework also allows them to think through what is their own goal and their own research question that they want to answer, and is this benchmark the right benchmark to use to help them answer their questions. So I think our that work would also be can be adapted and will be appropriate for that as well.
Yeah. No, I love that. Like maybe I'll also try to incorporate this framework because you are suggesting a framework to create the benchmark in the first place. So like it's a step, like it's a meta step before creating the benchmark in the first place. So I think that should be, and I'm curious because you have worked on evaluating and understanding benchmarks so much in the past. How do you think about the new LLMs that are coming out now? Like for example, OpenAI and lots of other big players. What kind of missing things? First of all, like, do you think those benchmarks, whenever they benchmark a new model versus an old one and suggest that this is the new model that they came up with, um, first of all, do these benchmarks, for example, for human communication, because ChatGPT and those kind of models are meant to communicate with end users who could be from different backgrounds, and they can be inputting any kind of queries, right? Like it can be medical related, just career related, or just open-ended conversations. Do these benchmarks incorporate all of those parameters, how you would as a person who has understood benchmarks a little bit more, do you think those benchmarks cover that, or like what one thing that is missing across these benchmarks when they report these technical reports they come up with saying that GPT-5 was better than GPT-4 and so on and so forth?
Yeah, I do think there's a gap. And I think this goes to a fundamental issue, which is that I don't really know what general purpose means. So in the sense that there are these models, they are marketed as general purpose and they're aimed to be used to solve any tasks related to language, I guess. But then they report benchmark numbers, and this benchmark numbers reflects some mixture of a range of capabilities that primarily its researchers decided are interesting to include. And so that means that you have a whole bunch of performance numbers, and the new models are usually better at maybe most of them, but maybe not all of them. And then they compare against the older models, and it's hard to conclude from that how what it's hard to say what we're supposed to conclude from that because general purpose is not well defined, right? It's here you have a collection of a mixture of numbers, and then for a particular downstream use case in a particular setting, it's going to be perhaps a different mixture of those capabilities that will matter. And so then there's a gap between the what's reported in the results in the benchmarks versus what's needed in the particular deployment scenario. So I would say this is why often, if you talk to people in industry, they'll say things like, "Oh, we know this model has the highest benchmark numbers, but actually we prefer this other models because when we use it, it just seems to be better in some way. Like they have this intuitive understanding or feeling." Or this is also why there might be cases where there might be other people who use the models in anticipated ways, and the models fail in uh, spectacularly, and they make some basic errors or they cause harm, and because maybe some users fall in love with the language model and issues like that. So I think there's a gap. There's a gap between what's reported and what they actually are used for.
Right. And just to double click on that, like I would imagine, like for example, if we have LLMs that are specific to coding, we can have like benchmarks that are specific to software engineering, coding challenges. But let's say if you were to design a general purpose chatbot that can be used by people with different backgrounds, would you ideally have benchmarks on, let's say, n number of tasks where you define these tasks are like the most used tasks by end users, and hence I'm benchmarking my new model across these different data sets? Would that be the ideal way to go forward and report these results, or you would suggest like going even a step further?
I think that's the start, right? So at least being clear about here's a number of downstream use cases with certain kinds of audience groups in mind, and then you can evaluate for those and deploy in those settings. Yeah, I think that's a good start. The challenge will be that people will always break your assumptions. The users will be smarter than you, and then they'll start adapting and using the systems for different purposes in different ways. And then you'll have to figure out how to handle that. But I think a good starting point is at least to maybe instead of saying general purpose, we can say multi-purpose, and then we can say that here are the things that it's being validated for, and here are the things we think we have good evidence it might work well on, and then there might be others that are unknown.
I see. Yeah. And one last question I have on this understanding like these benchmarking things is from a evaluation perspective or from a benchmarking perspective, how do you differentiate the terms like which is frequently used and often misconfused is intelligence, general purpose intelligence versus reasoning? How are these two things tied together, and like how you look at these terms when you are evaluating? Like, should benchmarks be different when we are saying like it's a general purpose intelligent model versus it can reason? Because there are like so many models thrown out there saying that they can reason with like chain of thought prompting and like different techniques that have been proposed. How do you look at these two terms?
Yeah, I think both of these terms are heavily overloaded and used in many different contexts. So I think you have to look at who is saying that and the particular context in which those terms are used to interpret them. So I would say that general purpose intelligence has certain connotations, but at least to me, intelligence is maybe a multifaceted thing. And that I tend to try to decompose that into some capabilities or skills that are easier to think about and easier to define. And then I would say that reasoning is also very overloaded. So one major conflation I see is between the mechanism versus maybe the abstract process that you can model. So when by default, I think of inference and reasoning as something like there's some implicit information or knowledge in a system, and you're trying to make it more explicit in some way. This is a very traditional definition to draw some conclusion. And that's kind of independent of the mechanism. So like a bog standard neural network with activations, and it might be feed forward or whatever, transformer, whatever, it can have a whole bunch of computations that results in the behavior that corresponds to reasoning. Or maybe you could have a symbolic system that does that, and that can result in reasoning. But I think the conflation that I see happening is that there are mechanisms that are also called, let's say, reasoning models or sometimes thinking models, where there's a mechanism, like they have a particular way of prompt format and structure, and then they're adapted and fine-tuned towards having the models use that format. And that has also been called reasoning or sometimes thinking. And I think it's important to separate those two. So there's the mechanism that it could be very clever, it could work, but that's separate from the underlying abstraction or the underlying process that you're trying to model and get the models to perform in some way.
I see. I see. So basically, you are suggesting that making the prompting or like thinking process and dissecting them into multiple prompts and calling that as reasoning should be much different than actually making sure like the training strategy incorporates a much more fundamental way of making the model understand a basic concept and hence learn reasoning. Is that like, did I get that correctly, or like what is the
I'd say
difference
both
between
of what you said, those are both more to do with the mechanism. It's more about how you intervene on the model, perhaps, or how you get the model to do something in a particular way in order to achieve some outcome. And then against that, you have the other side is the more abstract conceptualization of how you abstractly derive some conclusions from some information. So I would say let's keep those separate. So I would say the latter is more like a reasoning or inference in an abstract way, and then you can then model that in whatever style that you want with the mechanisms in your large language model or in your, say, symbol processing system or whatever.
yeah, yeah, that definitely makes more sense. Because in general like these terms, and coming from like a non-NLP background, I often find confused as to like these two questions that I always keep on asking is, first of all, like how do exactly we benchmark these different models? Sorry. Is when I say one model is better than the other, like we all often see big labs coming up with different models that are constantly beating the other models' performances, and it's very hard to evaluate. And as an end user, these are like gigantic models, right? So it's like very hard to actually understand what's the difference. Like when GPT-3 came with GPT-4 and 5, it's very hard to see the tangible differences. Versus if it's a task specific model, it's easy to find that, okay, if it's a model good at chat versus the other one is good at software engineering versus the other one is good at retrieval. But apart from that, as an end user, it's so hard to evaluate and make sure they are living up to the hype and standard. So yeah, thanks for answering to that. But to switch gears and understand these large language models from a safety perspective, I know you have audited and also worked on a bunch of data sets called helpful and harmless data sets that is frequently used by big lab and frontier labs and frontier models, including Anthropic and maybe more. One thing when I was reading through that report is you did say that safety is being treated as an undefined bundle. Can you maybe elaborate more on that? And first of all, like feel free to give a brief primer on what that work was entailed to do, and like also comment like what exactly do you mean? Like how do these labs handle the safety bucket in these scenarios?
Yeah, sure. So this is more work by Hala. So in this work, what we did was we looked at these existing paradigms in the AI safety literature, and one of them has to do with these qualities, as you mentioned, such as helpfulness and harmlessness. So in the original setup, what they did was they asked human annotators to look at some possible alternatives for model outputs, and they asked them to annotate which one they find to be more helpful and which ones they find to be less harmful. And there was also honesty, which is another quality that they defined. And then based on these preference judgments, they use the preference judgments to then further fine tune and adapt a language model. So and so that's now famously called RLHF, right? Reinforcement learning with human feedback. So in this work, what we did was we audited the data sets that they produced, and we also looked at some of the design decisions that went into how they came up with this process and what the process looks like. And so a lot of the concerns that we had and pointed out will be tied to the earlier points that I mentioned during our discussion, in that safety and specifically harmlessness is kind of considered to be just one generic facet that people can annotate for. And so the annotators, for example, would just be say, which one do you think is less harmful? But there's less of a description of the particular societal context and the deployment context of the technology. And so, as you might expect, then people would annotate, oh, if this output contains maybe like a racist term, or if it contains descriptions of violence or something, then they might mark that as harmful, right? Or not harmless. So that's fine. But then when we looked at the data set, it also seemed like people were also marking just irrelevance responses as being harmful or not harmless. And so essentially what you end up with is that the safety, because it's not well defined and it's not broken down into all of the different facets of safety, it becomes a general catch-all term for all sorts of potential issues that could exist in that output and that people annotate for. So yeah, so that's what we mean by a bundle. It's a bundle of other potential issues that get lumped into one, and it's left up to the annotators, who are assumed to be in some sense sovereign and getting to decide what to label and what not to label. So that's the main issue. And then there are also just other maybe more operational issues of like some data quality issues which will exist in maybe a lot of data sets, but that might further impact model performance if you fine tune on this. Yeah, um, part of it is that some of the definitions are not complete, right? So if you think of a notion like toxicity, is this output from an LLM toxic or not? Well, that's very context dependent, I would say. So you might say that, oh, if it contains a derogatory term, then it's toxic. But at least in human to human conversation, sometimes people using these derogatory terms is a way to reclaim those terms. So we've seen examples of that, and then they know they're no longer they're not derogatory in that context between those people. Uh, and so then if you think about this, then that means it's possible that if you flag a model output as derogatory, that itself, sorry, as harmful when it contains a term, and the context is not considered, that itself causes more harm. So there, I would say that there's a misspecification of the definitions. So there are components that are inherently missing, so that it's not possible for the annotations to be high quality. And another effect is that if you leave it up to people to decide on what's harmful or not, and then you fine tune on that without much further thinking about this, then you can lead to models that exhibits other unanticipated behaviors which cause other kinds of harm. So for example, one thing that we found was that there's, as you expect, there's a difference in the distribution of words between the helpful portion of the data set and the harmless portion of the data set. So in the helpful portion of the data set, a lot of it, for example, was about like food. There's like an information request for like, oh, tell me about how to make this dish or something. And in the harmless portion of the data set, because it's about distinguishing harmful outputs from not harmful outputs, then there were all of these then there were a lot of, let's say, demographic terms, and then and in addition to like the derogatory terms and so forth. And so what happens when you train LLM and adapt it onto this data set with RLHF is that you get um, what is being called in the literature as exaggerated safety behaviors. So it means that any query, even if it's otherwise innocuous, that contains, for example, one of these demographic terms, will be flagged as potentially harmful, and then the system will refuse to answer that. And this causes issues because then maybe you're just interested in like uh, this group of people, maybe they have dietary restrictions, and can you tell me about that? But then that's flagged as like, oh, I can't answer that because I think this might be a harmful query or something like that. And so then this means that then these systems produce a new type of harm, which is a quality of service harm, and that they disproportionately help queries related to say, one group over another. So these are some of the potential unanticipated outcomes that can arise because the notions are not very clearly specified in the first place.
Yeah, that makes sense. And yeah, this can, like, in many ways, I can understand, like, once we don't have these guardrails in place, models kind of learn these biases from the training data sets indirectly. So it's like more like a reflection of what it's out there on the internet, and maybe it amplifies it like much more of a higher magnitude, and it creates more harm than actually minimizing or like making things better. But I would wonder, like, when big companies use these kind of data sets or these kind of frameworks, how much do you think when they try to remove these bias, how much of this work actually happens in the fundamental level so that these biases are not propagated, or are they more like fixes or like patches to an existing work just to make sure a certain kind of outputs are not generated that can violate some societal policies? Like, have you seen people doing any fundamental work when they are working with these large language models that fixes the issues from the ground up?
Yeah, it's hard to say. I don't know the inner workings of the companies training these large LLMs. It does seem like, based on the testing that's done and what's being reported, that it does seem more of an approach of patching issues as they arise. I think there is work on, say, filtering certain kinds of training data and so forth, and maybe there's other work that is of that nature of trying to intervene throughout the training process of the large language models. But then, in terms of the what I would say even more fundamental aspects of defining safety and defining harm, it seems it's not clear to me that a lot of that is happening within the large companies. And it's also not clear that there are major incentives for that for the companies, because this type of approach is takes a long time, and it takes many iterations, and so yeah, it's not clear to me how much of that is happening in the big companies right now.
Yeah. And just as you are sharing more about this. I'm wondering, it's a very hard problem to solve in the first place, right? Because this is a much more moving target problem. It sits at the intersection of like understanding how to make architectures that first of all locate these biases. So for example, you worked on these data sets and you figured out like what helpful data sets more focus on versus harmless data sets more or less focus on. And at the other hand, more like I don't know if social engineering is the right word, but to make sure like what how do we define these guardrails in the first place, so that like if let's say one keyword does not flag it as like a very innocuous or like a harmful substance, but combination of few words would count as a harmful thing, versus from another lens it does not feel harmful to someone, but it might feel harmful to someone else. So it's very abstractly defined. How do we define harmful substances versus not? So it always almost feels like a moving target problem. It's we don't know where exactly it lies, but like I understand, like I mean your work is to figure out where exactly the failure modes of all of these frameworks are. And I mean you have done a great job, so like just wanted to add my 2 cents on top of it. It feels like a very hard problem to solve in the first place. Yeah.
Absolutely, and I completely agree with what you said. It's a very difficult problem, but that's what we have to grapple with. That as AI scientists, we can't just be narrowly focusing on the technical issues if we want to make claims about impact on society, because chances are these systems will have impact on society, and then once you get to these notions of safety and harm, they are all highly contested, and then there are many perspectives, and so you can't really get away from that. But there are better approaches, and there are methods that are out there, and other people have social scientists have worked on related issues for many decades at least, maybe longer. And so that means that we don't have to start from scratch, and then it's about grappling with and sitting next to the complexity that is the societal impact and safety of AI systems.
Yeah, definitely agree. One other research work that I found very interesting while I was reading through your works is a paper called like stochastic chameleons, because I've seen like people talk about stochastic parrots. That's like the common terminology people use. Can you talk more about like what was the findings? What are the set of findings that you found from that work? Because from what I understand, it's more like understanding how a model will camouflage its error um, with making sure like what relevant and irrelevant context looks like. So can you paint a picture for people who might not know what stochastic chameleons are and like what were the findings and what was the rationale behind that research?
Sure, absolutely. So there's been this term of stochastic parrots that many people have come to know. So the idea here is that large language models are stochastic parrots because they learn from the training data, and they learn the form, the surface structure of how words are distributed with respect to each other, and they don't get direct access to the content or the meaning. And so therefore, because they're trained on this data, then on the test set, they will reproduce similar statistics, and so then what they come out is somehow parroting what they saw in the training data. And I think a related metaphor that sometimes that got some traction a few years ago is that LLMs are kind of like a compression of the internet, right? There's a zip file of the internet, and then you can somehow like extract from that some new language. So in this work, what we're saying is that we're not directly contradicting the whole hypothesis of stochastic parrots, but we're saying that the way that they reproduce the training data statistics can still result in interesting generalizations and interesting outputs and behaviors that seem to suggest they learn something about abstract classes. And so that's part of that. So we're part of the way to this terminology of chameleon. Okay, so first of all, it's about the fact that it's about training on words and word co-occurrences. But what can we do with word co-occurrences? So then the next issue is how we probe these models. So one major issue with working with large language models is that because they're trained on so much text, and because a lot of sometimes with the very large models, it's not entirely clear what text they were trained on or not. Any conclusions you can draw are kind of confounded because you don't know if you care about generalization, you don't know if they are producing an output because they're generalizing or because they're directly copying and reproducing some text in the training data. So for many purposes, this doesn't matter. You just care about does it work or not, I guess, right? For like a practical purpose. But for our question of like, what does it mean for a large language model to reproduce similar data to its training? This does matter a lot. And so then the way we got around this is we looked at the errors produced by a large language model, and we looked at the structure of the errors of the large language models. And so this is where the chameleon part comes in, because we were playing around with contexts and coming up with situations such that to see what the behaviors of the models are in those contexts. So what we did was we introduced this, we looked at this idea of looking at irrelevant contexts. So the idea is that you have a prior sentence, which is the context, which contains some irrelevant information. And then we have a second sentence, which contains maybe a query. And then there's a word in there that we see what the LLMs do. And then if they generate some hallucination, then we see if there's any patterns in the hallucinations that they generate. So for example, maybe the first sentence is about, I don't know, cars in Japan, because Japan makes like great cars. And then the second sentence is about who is the author of this book. Okay, so something unrelated. So because you're pairing these irrelevance contexts next to each other, the chances are much lower that you'll have seen directly that sample in the language model pre-training. And so then we can more reliably trust that any patterns that we see are based on some patterns in how the language model processes text and processes data. And so essentially our finding was that when the models make errors, a lot of the errors that they make can be predicted as a function of a combination of what's in the irrelevant context and what is in the current target query sentence. So in the example I just gave, I talked about maybe Japanese cars, and then the second sentence is about the author of a novel. And then what we found is that if the model generates a hallucination, it's much more likely to say that the author of the novel and the language of the book is like in Japanese, because it saw that it was about, if the first sentence was about cars in Japan. And so then that means there's some kind of systematic way in which the language models are hallucinating or generating these factual errors. It's taking the class information from the current sentence. So it knows that in this context, I need to generate a language. Like this book is written in this language, so I know I need to generate some language, but which language it generates is maybe another feature of like that word. And it tries to extract it, and it finds this irrelevant sentence in irrelevant context, and it finds that the feature is the language spoken in Japan. And so then it plugs it in, and that's why it comes up with this output of Japanese. So this goes to show that there can be systematic ways in which LLMs generalize, even though they are trained uh, to reproduce word statistics. And so this might go to show that LLMs can extrapolate. It's just that it's not so what our experiments show is it's not a reliable or necessarily human-like way that it generalizes, right? It's like taking some irrelevant context, being heavily influenced and maybe primed by it, and then producing some combination outputs, which is still wrong. But it also means that sometimes when it does get the answer right, it could also be relying on this mechanism of recombining features of like things next to each other to produce the answer that happens to be right, rather than using a process that is maybe what we think should be the correct process for deriving an answer.
Yeah, yeah. And this was like such a fascinating insight, like even in general, because in in last year or so, like I was so much fixated on understanding like why large language models hallucinate. And a bunch of people would come up with the answer, which was not a technical answer, but like it says the more you prompt a large language model, the higher probability is to get to the right answer, given that it's a known problem and you know what the answer lies. And this kind of answers like in a very backward fashion of what you shared, right? Like for example, if I have like an irrelevant part and a relevant part, maybe there's a high chance that the model will offshoot the target or basically give me some hallucinations that is not reflective of the real answer. But let's say if I add more context, maybe ask more prompts later on, it gives it further direction and maybe dilutes the irrelevant context and maybe up like makes it pure for the relevant context, and hence it gets to the real answer. So I mean, your findings are like somewhat complementary to what we kind of know already, but like in a much more rigorous fashion. So I was just very I was just feeling very happy reading that paper, that maybe now it makes more sense. And maybe just for personal use, if people were to just use one prompt to get their answer, maybe they can intentionally dilute it with with an irregular or irrelevant context, and then evaluate how the LLM behaves. Like that's their way of fact checking if the model is behaving perfectly. But I would imagine, like with more training data and like much more bigger architectures, maybe it would be very hard to spot this. Again, this does not uh, alleviate this problem, but it's very hard to figure out for people like us.
Yeah, I think that's a really interesting comment you made that people are themselves adapting to the LLMs and they're figuring out, oh, what do I need to put in the prompt to get it to uh, have a certain kind of behavior. So I think that's interesting. And I also think that maybe this also, your comment and your insights also maybe explain partially why say chain of thought and other methods like that work is because it's like the model creating additional contexts and then using that to then try to do some kind of higher order statistical correlation analysis to generate some output. And maybe the way that you do that causes it to maybe hallucinate less or have some output that is in general more performant in some way. Yeah.
Yeah. And one thing often people kind of miss when they are interacting with large language models is there's almost like a regression to the mean effect in all of these outputs, right? Like you pointed out earlier, at the end, these large language models kind of model these distribution of words in a statistical fashion. So whenever I'm expecting, let's say if I'm asking a very, like this is something I learned when I was graduating, and at the end of my PhD, I was like kind of struggling with job search and everything. So I asked chat gpt that, okay, can you fill up or maybe create an abstract based on this whole thesis, because abstract, like I was leaving abstract to the last part when I was writing my thesis. And I kind of figured out, because the thesis that I wrote, it had like limited information already out that the model was trained on, it made a bunch of outputs that were not clearly relevant. And that kind of made me wonder that at the end, large language models will, or large language models will work out great where you're expecting a behavior that is kind of an average that has been already reported by a lot of people. But if you're expecting it to behave in a fashion where it's like very low probability, for example, a truly novel sentence or like a poem, like where the data does not exist, it will just hallucinate a lot or maybe like offshoot, and the experience of working with chatbots like would be very bad. So whenever I talk to people who are like using it for research or like something, extracting some novel information, I like, at least people who are using LLMs in that fashion, they struggle a lot. But if I'm just searching up something on the internet, yeah, sure, LLMs would work great, because millions and there's a millions of data points that point to that particular direction. But where you don't have any information, that's where the true test of LLM really lies.
Yeah, I guess it depends on the setup and the amount of novelty that you want in the output. So I guess what we're saying is that it can extrapolate, but it's not extrapolating in a necessarily in a human-like way. And so if you're for your use case of creating an abstract, you need it to be correct, right? You need it to reflect what's in the thesis. So then maybe that's why it has all of those errors. But if there are other instances where you want to extrapolate by recombining language, by recombining patterns and features that are in the data, maybe it's okay, right? So then it depends on exactly how you're using it. So,
Yeah. But do you see the merit to a lot of papers and like tools that are being proposed nowadays, where you have agentic framework for doing research? Do you think these kind of frameworks in general, not right now, but like let's say in the next 5 or 10 years, can be capable of doing something novel synthesis, like as a professor or like someone like you might be able to do? Do you think these agents would at least have some hints or like some aspect of like doing novel research in the future?
yeah, I think so. I don't think it's we can rule that out. So because if you recombine novel combinations of things, you might get something new, right? So, and we're already seeing that in say the some more maybe well scoped domains like drug discovery or molecule design or something like that. So I don't think that's like out of question, but I would say it most definitely biases the process. So it's going to favor certain kinds of discoveries or favor certain kinds of hypotheses that it can get by generalizing in the particular linguistic way that it can. And there'll be lots of scope and room for innovation and human insight for just entirely out of the box ways of thinking, which probably it'll be less likely that it'll be able to do. So I would say that either I would so first of all, I think of these as tools. So I think of them as okay, you have a framework, it can propose hypotheses, can do lots of things. And then you can use it either in an assistive way to help you do literature search or whatever, or you can use it to maybe come up with some new hypotheses, but it'll be biased in some way, and you cannot totally just let it loose and do its own thing. It requires you to be critical, in the sense of applying your critical thinking skills to think about what it can do and what is likely going to be biased on.
Um, Definitely. Like I'll wait for that day. Like once we have this agentic framework that can do research in a reliable fashion. But as of now, in my personal my own opinion, like I feel most of these chatbots are like really regressing towards the mean, like where it sees most of the words diverging towards, not in a novel fashion. But yeah, I'll wait to see that day for sure. One other use case that I wanted to touch upon before we move to more general questions is one of the most commonly used use case of these large language models is summarization, right? And in some of your works, you have also explored like how faithful these large language models would be when they're summarizing. What are some of the ways that you have found to be like the most reliable fashion to evaluate whether these large language models remain faithful to their original source text?
Yeah, so in our work, we use several approaches. Some approaches are based on some post-editing step. So a lot of the work has been to separate the initial summary generation from then a second step process of looking at the summary and fixing the issues. For example, so there was a one paper quite a bit earlier where we it was before pre-trained LLMs. It was, and the idea there was rather than generate the summary word by word, we generate edits to the source text, and so this was work by my former PhD student Yue Dong, who is now a faculty member at UC Riverside. And so then, so that is that style of summarization system. It directly says that okay, we want to separate the learning of all of like the language properties of the target language and like grammar and so forth from the contents and reasoning about what to keep and what to throw out. And so that was an early reflex, and then a early version of this. And then later on, in the context of hallucinations in abstractive summarization systems, then it showed up in this idea of having two steps of like generation and then post editing. So that's one approach. Another approach that we've pursued in my lab is to look at the different kinds of hallucinations that are possible. And so then this is work by another former PhD student, Meng Tao, where we separated hallucinations that are factual from ones that are non-factual. So it turns out that in the context of summarization, you can talk about factual hallucinations because you can talk about, say, additional context or information that is factually correct with respect to some well-trusted source, but they're hallucinations because they don't show up in the source text, but they appear in your summary. And so in that work, we found that there are ways you can statistically distinguish factual hallucinations from non-factual hallucinations. And the key distinction is to look at the change in probability of generating some entity token just by a pre-trained language model versus by a model that has also read in the source text. So it's a very intuitive idea. So if something is a factual hallucination, then it should already be have like a higher probability, even before reading the source text. But if something is a non-factual hallucination, then that should not be the case. And so by using these two features, we were able to distinguish between factuality and factual entities or not versus hallucinated entities or not. So yeah, so it turns out that there are some statistical cues, and in later work, then you can look at like some mechanistic interpretability stuff to look at how there might be different ways to look at where in the model's activations things are going wrong, in order to identify hallucinations of certain types.
Right. And do you have any intuition towards like first of all, yeah, I mean this is like very useful key points and findings to understand where factual and non-factual hallucinations might lie. Do you have any intuition like what we can improve in the training strategies, or is it like a very unsolved problem to make sure model for sure, like first of all, a does not hallucinate on factual things, because yes, that's the whole point of like having LLMs as a confidant. And secondly, make sure they also don't hallucinate on non-factual things. Like, do you have an intuition? Does it have to be I don't know, like annotated data, like more annotations during the training process, the training architecture itself? What can be fixed?
Yeah, I think it's going to be a combination of things. So I think one is definitely the training data and what you identify as factual or non-factual or supported or non-supported. I think another is going to be more on the modeling side. So I have this intuition that models are currently not good at distinguishing between different possible worlds in some sense. So in language, we often say things in a counterfactual way. We hypothesize, we say that if this is true, then within this context, something else happens. And I think that's kind of an important capability that so people, we do this all the time. We talk about imagined scenarios, and in this context, certain things happen. But then it's almost like whenever we create a new context, we add something to a stack and then we talk about it. And then we create another context, we add it to the stack again. And then at some point, we pop the stack and we go back to a previous context, or we go back to the real world in the end and talk about stuff that we believe to be true in the real world. So it's like we often talk about truth and factuality with respects to a particular situation. So just imagine, say, novels or plays or something, right? So within this particular world, maybe it's the case that people can travel to other planets and they can and you can talk about the politics there or whatever. But then in the real world is different. So what this means is that a lot of the language statistics you have to really get very high order language statistics to model this type of behavior. And I believe that having some way to analyze if language models are creating these local situations in some sense would be interesting and important. And then if you can figure this out, it might reduce the amount of hallucinations because for your particular context, then you can then talk about what's true or false or supported or unsupported with respect to that context and not just with respect to the general statistics that are learned by a language model. So that's an intuition that I have, but I'm not sure if it's been implemented yet in current language models.
Yeah, yeah, that is very interesting, definitely. And one last question that I have before we move to like more general questions is, like I know like this has been talked about a lot in the broad field of LLM and large language models in general, like any large vision language models, large action models, and so on and so forth. How do you feel about the whole idea of scaling these large language models? I think there's a power law that people have been suggesting in the original scaling laws paper. Um, there's a trade-off I feel in between scaling these parameters versus getting model outputs. I definitely do see there is a diminishing returns trajectory nowadays with scaling these models. But I wonder, like, since you're working in this field for a long time, how do you feel about the whole idea of scaling these models, scaling the data sets, scaling architectures until you get a certain set of performances? Do you see the true value people investing efforts into that, or do you think there's a very high scope of pushing researchers towards like a new architecture or like more efficient models that is like right around the corner? What do you feel about that?
Yeah, I think scaling is nice and it's been responsible for a lot of performance gains on the benchmarks. I think we are probably at the end of the era of further scaling, just because, at least for text, because we've consumed all of the useful text that we can that's out there. And sure, we're generating more text, but then now you have additional problems that a lot of the text that's generated is itself the output of other LLMs and so forth. So at least in terms of data, it's not even clear how we can further scale. Because also remember the scaling laws, they're like exponential, right? So it's like you need another order of magnitude to get a linear order of improvement on the performance numbers, however you measure it. The other issue with scaling is exactly that. I think it's a problem that you mentioned earlier. It's not really clear how this applies to, say, smaller groups that are not well represented or not in the statistical median of the distribution, or close to the statistical median of the distribution. Uh, yeah, in those situations, maybe scaling could in principle solve it if you just have a model that can account for all these contextual factors, but maybe that's not the most efficient way, and that you need some more targeted interventions to ensure some other notion of fairness or safety or something like that. So I do think there's a lot of scope these days to think about many points of intervention along the LLM development pipeline. And yeah, even the large companies, when they release new models now, they're not boasting about just the scale anymore, right? They are also boasting about efficiency, and they're boasting about how much money does it cost to train the model, and it's lower than before. So yeah, I kind of think that yeah, we can't dismiss scaling, but it's now going to be about all of these other issues that are also relevant, and efficiency is going to be one big one, and safety and so forth. And then for those, then it's not really clear that scaling by itself is the answer.
Yeah. And I wonder, like, has scaling, like, how does the chart of scaling look like across hallucination and reasoning? Have you seen a decrease in hallucination and like improved reasoning capabilities when we talk about scale, or is it like the static benchmarks that people have been benchmarking on, that is only improving? Like performance on reasoning and hallucinations also improve with scale?
I think they all improve, but I think we have an evaluation issue, as you alluded to, in that they tend to be evaluated on static benchmarks, or benchmarks of these like human preference judgments, like chatbot arena or whatever LM arena. And so then they don't necessarily indicate that the models will perform well or not hallucinate in new situations or unusual situations. And so yeah, so at least I still see hallucinations and factual errors all the time in like AI outputs that I get. Sometimes they're very subtle, but if you so it's they're not so easily noticeable unless you already are an expert or you know something about that domain, which is in some sense even scarier. But so yeah, I think it's definitely still a concern.
Yeah, makes sense. And to maybe zoom out a lot bit more, like one of the few questions that I have kept consistent throughout my podcasts is, since like this was the goal of like getting more newbies and like enthusiasts in AI getting into more into the space, I do like to ask towards the end of the podcast is one question that I get asked a lot, and I'm sure like you get much more asked because you're a professor like working with so many students, is in 2026, if a student were to come up to you and show some interest in AI, how do they get started? Like, because there's so much information out there, so much noise in terms of trends and also in terms of research architectures, right? Should I get started in robotics, computer vision, language modeling, and even the whole field of LLMs has opened up the area of ML engineering and ML ops, which itself is like a huge task. So how would you guide someone who comes up to you and says, I want to build a career in AI, but I don't know where to get started?
Yeah, so I think there are some basic things like taking courses in your university, of course, and maybe going beyond that and doing your own little research projects. But I do think that getting your hands dirty quickly is often very useful. So I think, yeah, even if it's not clear why you're doing it, just trying things out and downloading packages that are up there and getting started. Training systems is a great way to get started. I also think that if you want to differentiate yourself, it's about knowing the technical stuff very well, and then it's also about knowing something else. So it means that maybe you should consider doing a degree in CS or engineering plus something else. It could be biology. In my case, maybe I was into linguistics, or maybe even philosophy or sociology. And then it's thinking about how different ways of thinking from other fields could influence how you pick research projects or how you decide what's worth working on for yourself. So yeah, I think it's going to be a combination of bottom-up exploration and then taking courses and reading textbooks and getting this kind of more top-down view of how people think about a field.
Right. And I wonder, like, this is just one question for me. Like, I have asked a bunch of researchers as well. Is like, how do you filter out the noise versus signal when you're reading papers that are posted out there, because I feel people are just posting papers like Instagram posts. It's like very hard to filter out what's actually good versus not. Like, is there a mechanism that has worked for you to filter out good contributing works rather than just some empirical results that posted out every now and then on archive?
Yeah, I think you need to develop a good solid foundation in the field. So if you have a good understanding of the main problems in the field and the main paradigms and ways in which people think about these problems, it makes it a lot easier to understand the contributions of new papers because then it helps you fit them into your framework and your structure of the field. And this takes time to develop. It requires reading hundreds of papers in a field, and so this is the kind of thing where maybe summarization is not necessarily the best tool because it's like you need to build that structure for yourself inside your mind. It's not just that if you read the AI summaries, it will give you that as easily. I think AI summaries could be useful for maybe quickly absorbing and looking at new papers, for example, or new papers and new results. But you might have to also do the work of like reading the original papers, reading maybe older papers that establish some of these paradigms and establish the major problems in that field to build that internal structure for yourself in your mind and not in an LLM.
Yeah, I so much agree to that, because I do remember in 2024 when I was kind of getting started to use these large language models, or like in general any tools to summarize papers and quickly go through some of the trends, like because I was so much caught up like getting like the FOMO of like missing out on papers. And I asked LLMs, and like you said, it kind of dials down the information to such a point that you can't really gain any new information from the papers. And that's when I realized, if you see at any research paper, it's already a compressed version of such a good amount of science being done, right? Like it's heavily compressed into like 8 pages or like even 6 pages. And if you were to use a large language model on top of it, you are at the risk of losing information rather than gaining any new information. It most of the times just summarizes the abstract and conclusion, which is like the key findings, but it doesn't tell you or give you any important signals as a scientist or as a researcher. So yeah, that's a very fair point. And would you say there are any pitfalls that you see most of the people in AI nowadays picking themselves into? Like, for example, if it could be like a new researcher, like new student who is getting interested into AI, a PhD student versus someone in the industry. What kind of pitfalls have you seen most people running into, that you would, if you were to shout out and say, hey, please stop doing this, what would be that?
I think maybe this is betraying my age, but I think it would be like closely following all of the AI and machine learning blogs and taking that to be staying up to date with the field and chasing after every single trend. So yeah, this is not a critique of blogs or news sites about AI in general. It's that like you need to supplement that, and that like I think one trend that I've seen in some students is that they see a new technique, a new trend, a new yeah, maybe fad even, and then they immediately wanted to change all of their research and work on that new trend. And then a few months later, another trend comes out, and then they want to hop onto that, and then they keep changing directions. I would say that yeah, this is why I believe that it's important to know the fundamentals well, because often those trends, they are reflections of some longer term underlying program or paradigm, and it's more important to pick one of these underlying trends and or underlying ways of thinking and stick to that and really go deeply and innovate on that. So I think that's how you get success. It's not by always adapting to the latest technique and then immediately changing your research direction to work on that. It's more about having a clear understanding and goal of the field and pursuing a difficult and clear topic from that angle. And then sometimes the new techniques and new trends, they will be very useful and influential. You can adopt them. But then other times they're not immediately relevant, and then you can skip that particular trend. So I think that's what I would recommend, is that you should stay up to date as much as you can, but don't let the news immediately influence you too much.
Yeah, I so much relate to that because there was a very nice advice given to me by my advisor when, and this was like a bit of context to that is I was working in medical imaging space from 2020 to 2025, and in between vision transformers came out, right? And you might also know like the whole how the trend picked up. And me as a young student, I was seeing these impressive results that are being published by NVIDIA and like a bunch of big labs at the time who were working in medical imaging space. And I was so much intrigued to try out vision transformers that I broke like day and night to get my vision transformer working on a GPU that didn't have much GPU bandwidth. And later on I learned that my data set wasn't enough, so the results were like not that much impressive. And that's when my advisor told me one nice thing is definitely getting better results should be one of the driving factors, but it is more important to learn the research framework and focus on that rather than just beating yourself to getting like a bit of higher accuracies, because in research some of the times you don't get results or maybe you get results, but it's more important to stick to a fundamental of this research framework, how we analyze results and go about making those changes rather than just focusing so much on like beating that accuracy. So like you said, it's very hard to not fall into the trends, and I hope looking back I can see why this advice makes sense. But hopefully people who are listening to this within this whole whirlpool of thought, they can get some benefits from this advice. So yeah, thanks. These are the like I think that's the end of questions I had for you. Thanks for sitting through the whole podcast and answering each of these questions. I know evaluation in large language models is going to be like a very important field. Hopefully people, even like end users, are not directly responsible to learn this, but it's very useful to educate and literate people on like how the failure modes of these large language models are, so that people who are using this on a daily basis have some better context before interpreting these results. So thanks for answering all of these questions and sharing your research. I'll leave link to most of the papers that we have talked about so that people have some context before listening to your advice. So thanks Jackie for being on the show, and I hope you had fun.
Yeah, I definitely had a lot of fun. Thank you so much for the invitation. It was a pleasure to chat about these topics. And yeah, I'm a prof, so I like blabbing on about things. So this was great. Thank you very much.